Okay, so let's look at algebraic fractions in this recording, specifically simplifying. Now, with algebraic fractions, I do find that students can understand how to do these, but generally, GCSE and Excel do put particularly difficult questions on for this topic. So it might be worth looking at all the recordings first and having a go at the past exam questions. Okay, so to simplify an algebraic fraction, let's start with just simplifying basic fractions. How would I simplify 15 over 25? Well, I'd be thinking it's got a common factor of 5. I'm going to divide the top by 5 and the bottom by 5, which gives us 3 over 5. Similar with an algebraic fraction. Now, I'm going to, the common factor is 4. So I'm going to look at the numbers first. 4 and 8, common factor is 4. So let's divide the number on the numerator by 4 and the denominator. 4 divided by 4 is 1. 8 divided by 4 is 2. Now, what's x divided by x? Anything divided by itself is 1. Right, 10 divided by 10 is 1. 15 divided by 15 is 1. X divided by x is 1, so they just cancel out, and we're left with y. So the final answer is just y over 2. Okay, let's look at the numbers first. Highest common factor of 20 and 30 is 10. I'm going to divide them both by 10. It leaves us 2 as the numerator, 3 on the denominator. X divided by x is 1, but let's just look at this in a little bit more detail over here. We've got an x on the top, and I've got x times x at the bottom. So you can see this x cancels with this x to make 1, and we're left with an x on the bottom. Similarly for the y's, but we have 2 y's on the top and a single y on the bottom. So the y's divide to make 1, and the y is left at the top. So each of your letters cancel out, but if there's more of the letter on the top, you're going to be left with numbers on the numerator. Similarly with the denominator. Let's just look at this last question for here. Highest common factor of 14 and 7 is 7, so I'm going to divide the numerator by 7 and the denominator by 7. 14 divided by 7 is 2, 7 divided by 7 is 1. Now, if I wrote it out in full, we have x times x times x times x at the top, 4 of them, 2 x's on the bottom, 2 of them cancel out, which would just leave x squared on the top, and really we only have 1 at the bottom, which is the same as 2x squared. I would suggest having a go at these 4 questions yourself. Put me on pause and pause when you're finished to see if they're correct. Question 1, common factors 5. Let's divide them both by 5. X's cancel out, and you're left with a y at the top. Question 2, again, common factor 5. M's cancel out, and they leave an n up here. Highest common factor is 12. P's cancel out, Q's cancel out, and leave an r on the bottom. Highest common factor is 10. Y's cancel out. One of the x's cancel out to leave you an x on the top. Have a go at these 4 more complicated ones. I think those last 4 are a bit easy, so put me on pause again and have a go at them yourselves. Highest common factor 7. C's cancel. The D at the top cancels one of the D's at the bottom, leaving a D on the denominator. Highest common factor is 4. There's 5 x's on the top, 2 x's on the bottom, so that would leave us with 3 x's on the top, which is the same as 3x cubed. Highest common factor is 10. No, it's not, it's 20. If you had have used 10, you would just have needed to carry on simplifying. 3 A's on the top, 2 A's on the bottom, we'll use an A at the top. 2 B's on the top, a B at the bottom, leaves a B at the top. Divide by 9. And then we've got 6 x's at the top, 2 at the bottom, would leave 4 at the top, because 2 of them cancel out, and the y, there we go. Right, now, there is a misconception I find from a lot of students when dealing with simplifying fractions. A lot of students think, oh, I can just do this, these cancel out. It does not work like that. In all of these previous questions, we were never in a situation where we had anything like this and we cancel the p's like that, for example. We just you cannot cancel the p's there. Let me just try and explain to you why. So just to say that again, this is what you cannot cancel those x's. And why? Well, it's x plus 2 and it's x plus 3. So let's say, for example, x is, let me think of one that's going to work here. Okay, I'm just going to say x is 3. X is 3. 2 plus 3 is 5, right? 3 plus 3 is 6. That cannot be simplified. Just to explain that a little bit more detail. So it's like saying 2 plus 3 and 3 plus 3, isn't it? You cannot just cancel those 3 because the 3 on the numerator is part of like adding 2. It's not, it's 5 all in total. Which is similar here. If you can see, 3 over 8 doesn't simplify. 3 over 8 we could partition up as 2 plus 1. And our 8 we could partition as 2 plus 6. We just couldn't do that, and it wouldn't simplify to 1/6. Impossible to do. Okay, just to lay my point even more. If you were asked to simplify the fraction 10/12, we'd be thinking, well, the common factor is 2, so if I divide the numerator by 2, I get 5, and the denominator by 2, I get 6. It would simplify into 5/6. Let me just split that up. As I was kind of discussing before, we can write 10 as 2 times 4 and 12 as 2 times 6. Now we've got them multiplied, you can see the 2's cancel out, gives us 5 over 6. So you cannot simplify when we're just like adding an x. The x's do not simplify in this example. But if it was like this, so I suppose we could have 5x over 6x, you can see the x's would simplify. Hopefully I've explained that in enough detail. Okay, what about when we've got something like this, 10c plus 25 over 15? Always algebraic fractions, and this is what people miss when we get into more complicated examples. Try and factorise if you can. So if you're staring at a algebraic fractions question, you can't see what to do. Try and factorise it. So this factorises into a single bracket. Nope, not 5c. 5 bracket 2c plus 5. And then we can see now on the numerator and denominator we have 5 as common factor, so we divide them both by 5. Gives us 1. and 1 multiplied by 2c plus 5 is just 2c plus 5 and 3. In this example, really, what we could have done is divided everything by 5. That's another thing you might get into the habit of doing. As you can see, we get the same answer. Next one. Ooh, more complicated again. And let's just make sure we understand we cannot do that. Let's see if we can factorise. Factorise, hopefully you recognise it's double brackets. If you need help factorising, there are plenty of videos on that topic. So we need two numbers that multiply to get 4 and add to get 5. What are they? 1 and 4. So we've got x plus 4, x plus 1 on the numerator. Denominator, we have two numbers that multiply to get 3 and add to get 4. 1 and 3. Now we can simplify. X plus 1 simplify, cancel out. So my final answer is x plus 4 over x plus 3. Okay, you may be ready to have a go at some yourself. If not, maybe just watch a couple of examples. I've got 6 for you to have a go at yourself. Two numbers that multiply to get 9, add to get 6. 3 and 3. Two numbers that multiply to get negative 15. Add to get negative 2. It's got to be a plus and a minus. 5, x minus 5, x plus 3. Because 3 times negative 5, negative 15, negative 5 plus 3 is negative 2. Final answer, x plus 3 all over x minus 5. 2 is just a single bracket for the numerator. Denominator simplifies 2, factorises 2, x. So two numbers that multiply to get negative 8 and add to get 2. 4, x plus 4, x minus 2. Cancel out. X over x plus 4. 3. Two numbers that multiply to get 10 and add to get minus 7. They've got to be both negative. X minus 5. X minus 2. Multiply to get minus 10, add to get 3. Plus 5. Minus 2. 5 times negative 2 is negative 10. 5 take away 2 is 3. These cancel. Okay, question 4. X plus 5, x plus 3. Two numbers that multiply to get negative 12 and add to get negative x is negative 1x. So add in to give us negative 1. Minus 4, sorry, x minus 4. X plus 3. The x plus 3's cancel. And we're left with x plus 5 over x minus 4. Question 5. X minus 4, x plus 2. X plus 10. X minus 4. And this last one here. x plus 6, x plus 4. Right, careful with this bottom one here. Right, it's difference of two squares. So it's x minus 6, x plus 6. Hopefully you recognise that. Okay, these are the slightly more complicated ones, only because if you see the expression at the top, the coefficient of x squared is greater than 1. Again, there are a few different methods for this. I'm going to just look at the splitting down the middle method. So 3 times 4 is 12. So we're looking for two numbers that multiply to get 12, add to get the middle term, which is 7. They are 3 and 4. So we split the middle term here down to 3x plus 4x. Then we factorise into a single bracket, 3x bracket x plus 1. And then 4 bracket x plus 1. We're looking for the same term in each of these brackets, which we have. The answer is 3x plus 4 by gathering these terms together and x plus 1. And the denominator is x plus 1 times x plus 2, because 1 times 2 is 2, 1 plus 2 is 3. These cancel. Okay, have a go at these three now. Okay, I'm going to split down the middle at the top here. We need two numbers that multiply to get 3 times 2, which is 6, and add to get the middle term, which is 7. So it's 1 and 6, because 1 times 6 is 6, 1 plus 6 is 7. So we've got 3x squared plus 6x plus x plus 2. 3x bracket x plus 2. I factorise the left hand side plus 1 x plus 2. So 3x plus 1 in one of my brackets, x plus 2 in the other bracket. X minus 4, 3x plus 1. Let's split down the middle for the numerator this time. 5 times negative 6, negative 30. Looking for two numbers that multiply to give us negative 30, add to give us negative 13. They are minus 15 and 2, because minus 15 times 2 is minus 30, minus 15 plus 2, minus 13. So we've got 5x squared minus 15x plus 2x minus 6. So you've got 5x bracket x minus 3 plus 2 bracket x minus 3. So the numerator simplifies into 5x plus 2, x minus 3. The denominator is the difference of two squares, x plus 3, x minus 3, cancels out, 5x plus 2, x plus 3. Right, this next question, question 3. Need a little space to do this. Split down the middle. 2 times negative 2 is negative 4. A times b, negative 4. A plus b, 3. So we got 2x squared. Oh, hang on, what are my two factors now? Sorry. They are 4 and -1. 2x squared plus 4x minus x minus 2. 2x bracket x plus 2 minus 1 bracket x plus 2. Got to fiddle it a bit here because I know that if I've got an x plus 2 in the first bracket, there has to be an x plus 2 in the second bracket. And I know -1 times x is -x, -1 times 2 is -2. So one of your brackets is 2x minus 1, the other bracket is x plus 2. Right, let me just split down the middle with the denominator. 2 times 7 is 14. So we have 15. No, what have we got? So two numbers that multiply to get 14, add to get -15. They've both got to be negative, right? -1 times -14 is -4, so it's +14. And then we add them together, we get -15. So 2x squared minus 14x minus x plus 7. Simplify, factorise, 2x bracket x minus 7 minus x minus 7 minus 1 bracket x minus 7. So one of our brackets is 2x minus 1, the other bracket is x minus 7. Right, now finally we factorise them. Top bracket, the denominator, no, the numerator, 2x minus 1x plus 2 in the denominator. We get some cancelling out here. Final answer, x plus 2 over x minus 7.